In this example, we show in a nutshell how we are able to measure the tackiness of greases. So tackiness is a quality or a property of a grease, which can be shortly described as its ability to form threads. And this can be a desirable or an undesirable quality. The thread formation certainly makes it possible for greases to lubricate moving contacts more easily. But today there is no real accurate measurement technique to measure this thread length and also the adhesion of greases on some materials. Historically, for evaluating the tackiness, this finger test is being used, where you place a volume of grease between your fingers and pull it apart, and you observe whether you are forming any threads and how long they are. The problem with this is that it is definitely a user-dependent test, and we can see here that it is also speed-dependent. When you separate your fingers faster, you tend to get longer threads. So all these factors together have inspired us to look for a quantitative method and to try to simulate this finger test, this indentation and retraction that you are doing, but to actually measure what is going on. And the approach that we have used is an indentation extraction experiment, or an indentation retraction experiment. We've selected a copper ball as a probe, and we are going to push this copper ball into a volume of grease and then retract. And because we have a very sensitive and precise force sensor on this system, we can measure the forces involved with this experiment. And we can plot a force displacement curve like this, where we first get the indentation of the ball into the grease, which is generating a positive force on the sensor. And then we retract, and as the grease is pulling a little bit and adhering a little bit, we get a negative force, which we define as the pull-off force. And then we get the force that is gradually reducing. And during this time, we are forming the thread. So at the point where this force is crossing zero again, this is our definition for the thread length. Now we have this very precise measurement of displacement and force, so we can analyze curves like this and extract thread lengths and pull-off forces from some statistical experiments. When we do this, we can plot curves like this one, where we are showing the thread length that we have measured as a function of retraction speed in millimeters per second down here. And we are showing plots for a base grease without any tackifier added to it, and increasing percentages 0.5, 1, 2, and 4% of a certain tackifier. And we see indeed that the thread length is increasing with the amount of tackifier, which also corresponds with the subjective finger tests that we can show right here. So we have a correlation between the finger tests and thread length measurement. We have a correlation between the thread length and an increasing amount of tackifier. So this tool gives us the possibility to actually measure thread lengths and compare them. We can, of course, do this for different greases. We can do it at different temperatures. We can do it under different circumstances. And so we have a tool in hand that quantifies this thread length. As we are doing this research, we have also discovered that while thread length is increasing with tackifier percentage, in this curve right here, this does not necessarily mean that the pull-off force is increasing gradually with tackifier percentage. And we see that in fact the pull-off force is decreasing with tackifier, but also jumping up and down a little bit. There is no direct correlation between the pull-off force of a grease and its tackiness. Another surprising result we measured in case of another grease with another tackifier, adding 1% of tackifier to the base grease, we get a little bit of an increase of the thread length. And this is the performance of the base grease. But when we are adding 2% of tackifier, we get a serious drop in the thread length. And you can also see in the finger test that the grease has actually completely changed its consistency. It's become much more of a gel, and it doesn't form any threads anymore. So the method also allows us to really quantify and repeatedly measure these kind of effects, these kind of maybe unexpected effects of tackifier additives. So this first quantitative method for measuring the thread length of greases in pull-off experiments, it allows us to systematically research the effects of a lot of factors on tackiness. We can look at concentration of an additive, the influence of the base grease, the influence of retraction speeds and temperatures, and we can even change the probe, so we look at the influence of the metallurgy of the contacting materials. A lot of work has been done on this application already, and there is certainly a lot more details available in literature if you want to know more about this.